Hey, welcome back. It's Tuesday, another day of math. Woo-hoo. Today, we are going to talk about comparing and ordering fractions. We're going to build on what we did yesterday, and now we're going to put them in order. Three fractions in order from greatest to least here. You will need to pack it, open to this page. Three. You will need a pencil. And you will need to keep watching as you see the problems together. And we'll just finish that. Here we go. Hey, we're back. So just a quick review of what we did yesterday. We were comparing just two fractions, the 5/8 and 1/3, because the picture for you. Otherwise, I could cross multiply. 8 times 1 is 8. 3 times 5 is 15. This one's bigger. 5/8. I'm not going to do the rest of those. That's just a quick review. When you're ordering them, like this time, we'll do a couple of these. It has a picture for it. So if I look at the picture, here's 1/4. Here's 3/4. Here's 1/4. Here's 9/10. Which one's bigger? Obviously 9/10 is the biggest, and it's 3/4 and it's 1/4. No, my smallest is 1/4, then I have 3/4, then I have 9/10, right? Using the picture here, you can do the same thing. Least to greatest. My smallest one is my 3/8. Then I have 5/12, and I have 1/2. Now, if I don't have a picture to help me, and I don't have a number on, I'm going to skip those. And down here, I can do a couple of things. So the first thing I can do is, since these all have the same numerators, I am going to look at the denominator. Remember that rule. If the numerators are the same, whatever denominator is the smallest, that's your largest fraction, right? So if I'm going from least to greatest, my largest denominator is 8. That's my smallest fraction. It's like going back to that pizza example. If I break my pizza up into 8 pieces, and I break another pizza up into 6 pieces, another one into 3 pieces, if your pizza is divided into 3 pieces, it's going to be bigger if it's divided into 8 pieces, right? So 1/8 is the smallest, it's going to be 1/6, it's going to be 1/3. If they are all different, this is where I'm going to cross multiply all of them. So I'm going to start with my first two numbers. I have 2/5. I'm going to write on the side, and you can too, and 5/10. Then I'm going to compare those. And then I'm going to take 5/10 and 3/9, compare those. And then finally, I'm going to take the two that I have not compared yet, so 2/5 and 3/9, compare those. Now I'm going to cross multiply, so 25 and 20. And I'm going to circle the bigger number. Now I have 5/10 and 3/9. 10 times 3 is 30. 9 times 5 is 45. Circle the bigger number. Go down here. 5 times 3 is 15. 9 times 2 is 18. Circle the bigger number. Okay? Now I'm going to go through and I'm going to look. The one with no circle is my smallest number. So 3/9 did not get circled. So 3/9 is my least smallest one. Then I'm going to put with one circle. 5/10 has 2. 2/5 has 1. So 2/5 is my middle number. Now I'll look for the one with those two circles. Okay, 5/10. That's in order from least to greatest. Let's do one more of them. Let's do this one over here. So I'm going to compare. You should set up this way too. 3/8 or 12. 3/8 and 1/9. Then 4/12 and 1/9. So I have to compare all of them at least once. So that's 3 fractions. So 8 times 4 is 32. 12 times 3 is 36. Circle the bigger number. 8 times 1 is 8. 9 times 2 is 27. Circle the bigger number. 12 times 1 is 12. 9 times 4 is 36. Circle the bigger number. And I'm going to go through and look. Okay, least to greatest. This one does not circle at all. 1/9. This one has one circle. 4/12. And which one has 2 circles? 3. So I'm going to order. I know this seems like a long, tedious process, but it doesn't take too long actually, and you're going to get the right answer. So let's do a couple of these then. This one I can just look at it again. The numerators are all the same, so I can just look at the denominators. The smaller the denominator, the bigger the fraction. So 1/4 is my greatest, and 1/5, and 1/8. This one, they're all different. Okay, so now let's do this one. 2 6, 3 tenths, 5 8. 2 6 compared to 3 tenths, 3 tenths, 5 eighths, and then 2 6, 5 eighths. Cross multiply. 6 times 3 is 18. 10 times 2 is 20. It's bigger. 10 times 5 is 50. 8 times 3 is 4. That's bigger. 8 times 2 is 16. 6 times 5 is 30. That's bigger. So greatest to least, my one with 2 circles is 5 eighths. My 1 circle, 2 6. And no circles is 3 tenths. Okay. I'm sorry, page. I'm not going to talk about these because we have pictures and number lines to help you, so just be comparing them. Same with here. These ones. You can do these if you want, remember. You don't have to. Greatest to least and least to greatest. You are going to pause this in just a second, and you will do these 4 problems. And then unpause it, check your answer. Okay? Should have went 8 tenths, 2 fourths, 3 twelfths. And then these are all the same numerators, so just look at the denominators. 1/2, 1/6, 1/8. Down here, kind of the opposite. 1/8, 1/4, 1/2, 1/5, 3 tenths, 8 tenths. Let's do one of our word problems together. Let's do this one. Make the thing keep cat. He buys 10 tickets. Then he rides a roller coaster and Ferris wheel. Ken buys 8 tickets and rides a tilt-a-whirl. Who has used a greater fraction of his tickets? So Pete. He had 10 tickets total, and he rode the roller coaster and the Ferris wheel. So if you rode the roller coaster and the Ferris wheel, you used 2 out of 10, right? Ken had 8 tickets total, and he rode the tilt-a-whirl. Now I have to figure out, okay, who rode more. So I'm going to cross multiply. So I have 10, and I have 16. So 2 tenths is bigger. So the person who used a greater fraction of his tickets was Pete, because he used 2 out of 10 versus 8, 1/8, 1/8 is smaller. I said we were done, but let's just do this one too. L buys 12 tickets. And put 12 on the bottom. Pete buys 10 tickets. That's the denominator. Ken buys 8 tickets. Which of them will use the greatest fraction of tickets to ride the roller coaster? Oh, you know what? I told you this wrong because I didn't even look at the fractions over here. Yeah, so ignore that one. We're going to skip this one. I could just pause the video and fix this, but I'm going to do this one. So the Ferris wheel is 2 tickets, and the roller coaster is 5 tickets. So all of them, greatest fraction tickets to ride a roller coaster. So use 5 12, use 5 10, 5 8. Since the numerators are all the same, I'm going to look at the denominator. Remember, the smaller the denominator, the bigger the fraction. So 5 8 is my biggest fraction here. So that's my greatest fraction. So Ken used most of his tickets to ride the roller coaster, which makes sense because he only has 3 tickets left now for other rides, whereas Pete has 5 more tickets and Elle has 7 more tickets. Okay. If you want to work on those, great. If you don't, that's okay because we're going to IXL. Hey, back. So our IXLs today are in the P's again, and this time it's 14 through 16. So we will be comparing fractions with like numerators and denominators, comparing fractions using models, and benchmark fractions. Let's start with number 14. This one's greater. If the denominators are the same, we're going to look at the numerator. 3 is more than 1. If I have 3/4, and you only have 1/4, I have 2 more than you, right? That one's greater. Which one's less? 2, 6, 1, 6. Denominators are the same, so just come up with the numerators. Smaller the numerator, smaller the fraction. Skip ahead. Which one's less? This time the numerators are the same, the denominators are different. So remember the rule. If the numerators are the same, whichever denominator is smaller is a bigger fraction. So 1/3 is a bigger fraction. Oh, I'm supposed to do less. Ugh, I gotta read. I hope you're reading better than I am. Which one's greater? Numerators are the same, denominators are different, right? Which one is greater? If I have a cake and I divide it into 3 pieces and I get one of those pieces, it's going to be bigger than if I have a cake and I divide it into 8 pieces and I get one of those pieces. So 1/3 is greater. This one's less. Denominators are the same again, so just look at the numerators. 5 is less than 6. Okay. On to P15. Okay. P15 is comparing fractions using models. So same thing, I can look at the picture. Which one's less? Well, 2/5, right? Good. These ones, 8/12 and 2/3. If I look at the picture there, they are the same. So I would choose neither is greater, they are equal. Yeah. Same with this one. I think they look the same. And I can check because I can, okay, 5 times 2 is 10, 3 times 2 is 6. So yes, they actually are equal. Go back. I think you guys got that. Let's talk about P16. P16 is benchmark fractions. So benchmark fractions are ones you just should know by heart. Like money fractions. Like a quarter is 1/4. 50 cents is 1/2. So which benchmark is between 7/5 and 3/5? Well, 7/5 is more than 1 whole, right? 1 whole is 5/5. Here would be 7/5. And right here would be 6/5. And here would be 3/5. Another way to say 5/5 is 1 whole. So a fraction can be a whole number too. We'll probably talk about that. So a fraction can be a whole number, it'd be 5/5 or 1 whole. So 1 whole comes in between these two. So that's the benchmark fraction. Wait, really? Okay. So this one, between 10/8 and 6/8. Well, 10/8 is greater than a whole again. And 6/8 is greater than a half, so it has to be 1. Between 2/3 and 1/3. Neither of these are greater than a whole. So the one that would come between would be 1/2. What's it between 7/4 and 7/8? 7/4, that is greater than 1 whole, right? 7/4. 7/8 is less than 1 whole. But since they have a greater one and a less than one, you're going to think about, okay, is this number smaller than a whole, or is this number larger than a whole? Like this one, 5/8 is smaller than a whole, 1/8 is smaller than 1 whole, 1 whole would be 8/8. So the only thing going between there is 1/2. So that's that. You're working toward 80% on those 3. If you have any questions, give me a shout, text, call, whatever you need to do. If we don't get it figured that way, we can still work through Zoom. If you run through these really quick and you did your packet, or maybe you don't want to do your packet, practicing math facts would be a great thing to do too. You can always get better at those multiplication division facts that will serve you well in life. Can't tell you how many times a day somebody comes up to me and says, "What's 9 times 7?" Okay, that doesn't really ever happen unless I'm teaching 4th grade, but I do need to know that kind of stuff when I'm figuring out bills and how much carpet to buy for a living room or random things like that. You will use those, not just for school, but for life. So, good thing to practice. But have a good rest. Well, I'll see you for reading. Have a good rest of the time until I see you for reading. vi gets till näsan. Adios!